Okay, so during the last lecture we took a small detour and have played with the abstract class interface pattern, where we can create very easily binary compatible plugins that should work across different revisions and provide excellent binary compatibility. In this lecture we'll come back to our data panel application and add to it the support for actual binary plugins loadable externally. Let's quickly start it to see how much we already had done. So as we see, we have here the panel where we can load currently hard-coded plugins, which will be changed, and we have of course our display on the side. We should add, we can actually load one of them just for testing. We still need to add some functionality to show data here in the panel, but we can do this once we have added the plugin functionality to load external plugins, so that we don't waste time doing things redundantly. There are a few more things which we might want to add, like make the add plugin window more complex, with not just the name but also with the ability to add additional presets and stuff like that. But for now our goal is to add this mechanism to load external plugins as DLLs. Within our plugins we will be limited in as far as that we will not be using Qt, since then this would break binary compatibility, as Qt loads the Qt libraries dynamically, and if our UI would want a different version of the libraries than one of the plugins, then it would be a problem. Qt is not particularly well binary compatible in either direction, so generally you should just distribute your own Qt binaries with your project, and then that problem should be solved. But this also means that if you have plugins, then unless they are built for the right Qt version, the plugins themselves should not use Qt. And in principle, nowadays this is not much of a limitation. In the past, of course, Qt had a lot of very nice features which you did not had platform independently from the C language itself, but modern C versions have a lot of functionality included in the STL, which allows you to write reasonably platform independent code using only STL, and there is hence not that much need to use Qt. Main things that Qt is still really great at is it allows you to create the user interfaces, which for plugins one might not necessarily need. So ideally plugins would be more declarative, and if they would need to show some configuration window, they would rather just give a list of parameters and the actual UI would render its own config window and then just giving the parameters back and things like that. And the other thing that Qt is quite great at, which you also don't have in this shape in modern C, is this signal and slots mechanism, which is very convenient if you want to do things also in multiple threads and then have easy communication between the different instances. For the use case of plugins, this is usually not something that would require to be required. You can usually plugins will be more busy with doing like one task, and if they need some multitasking, then you have to implement this manually, but it should not be too complex, since usually there will be just maybe one or two worker threads per plugin and not like a complex interdependence of many different threads, which might complicate thread synchronization. So we will start by just we can copy maybe for starters our interface API stuff from our plugin demo to our data panel. Where was it? Data panel here. And then we will create our first plugin. So add a new project, dynamically linked library, next, and let's call it demo plugin. Data panel demo plugin, that just looks like the right location. Again, this gives us only a very basic DLL. It doesn't have almost anything that would be of much use, so For now we just copy from our other project one of the from plugin 1, just for example the plugin 1 CVP and H, that will allow us to quickly start demo plugin here. But let's rename this of course to demo plugin H and CVP. Demo plugin H and demo plugin CPP. Then we can drop this into the demo plugin, and then of course we need to replace a few things. So this will be, in principle we don't really need to care for this import and export, since we are not exporting any classes, so we could really just go with ignoring this whole complexity here and just doing it manually. Also we don't need a test function, so we only have like one export, make plugin, and the rest we only need to change here the names from plugin 1 to demo plugin. Zack H Zack. Good. So we have here our plugin. We could add here like such a organization folder so that we can add it's called the solution folder, so that we can add first interface API, so that we can easily refer to our files. Interface API Zack. Okay, then the dropping doesn't work. Existing item. Okay, good. So now in our main panel, where we have our plugin manager H, we will need to add a mechanism to load plugins. So we have already seen that we have quite a few functions. We have, for example, this abstract plugin factory. This will pretty much be a wrapper to call on our plugin the make plugin. But we also see here that this has like an ID and a name, so it would be convenient for us if we would add a few more things to the standard API here. So we will not make like an own plugin factory, which would be an own object exportable from the DLL. Instead, what we'll do is we will just add to our interface, like we had this test function, we'll just add other functions that gives us a name and a ID, for example. Or what we also could do is we could actually use the DLL name itself as the ID. So this will be unique enough. We wouldn't want to have multiple plugins which have the exact same file names. And the ID is just something that should be unique for internal reference. So we really would only need some getInfo or getName function. And since usually our goal would be to keep the amount of functions rather lower and have them return more complex structures, because then it's easy to add additional parameters and keep better compatibility instead of always adding newer and newer functions that do more and more things. So for this application, for this purpose, we will define as a structure as plugin info, and we need to think how this structure will be structured. So of course returning simple types is easy, but with strings that gets a bit more complicated. So in principle there are two approaches. One approach is that when the function which returns this structure is called, it will return a reference to an internal memory held by the plugin, and that's it. Or the other option is that it will take a buffer and a length and then copy into the buffer the required data. The latter approach is the more generally correct one, but in special cases other approaches are better. And in our case, since all the data that we want to return here will not really be subject to change, we can really statically initialize them when the DLL is loaded and then just give this thing out. Actually, we could use this opportunity also to just try to retrieve an address of a variable instead of a function name, so that we can directly reference the memory inside the plugin without the what's Umweg in English? Detour through a function that returns it. For now, we will do it with a function, then we will see how we improve it. So first thing, of course, we would usually, when doing such things, so with the function, it's usually quite reliable. If you just go for returning memory from a by name in a plugin or in a DLL, this is also reasonably reliable, as long as the names that you are using are long enough to be assumably unique. If you would go with an approach where you are getting exports from a DLL not by name but by ordinal number, which pretty much is like an index basically, then it's easy to just load some rogue DLL and then also be able to retrieve some address for some given number, because numbers usually just start at 0. So in such cases, you would want your data structures, if you are resolving those, to be marked with some recognizable and long enough to be unique pattern, so that you can validate. So such patterns are usually called magic numbers, but in our use case, since we will be using names which will be long enough to be reasonably unique, we don't need that. So we can start in from the get-go with relevant information inside our structure. So the first thing will be, of course, some sort of version. Let's go for a too long version, or let's call it API version. Then we will want to have some const char t asterisk plugin name. And for now, for our first version, this could already be enough. We don't really need more. So let's repurpose here a function to get plugin info, which doesn't take any parameters. It just returns us a plugin information structure. So we copy this, go to our demo plugin, and then we will have to export a second thing here. Plugin info, and we call it get plugin info, of course. Stack. Then we go to our plugin implementation. We might want to put such a thing on the very top, just so that it's quick to find. The make plugin, we could actually move up to next to the constructor, so that, or also move to the very top. Let's actually do that for both of them, but in a reverse order. Oops. So that kind of keeps things grouped together, that belong together. And here we will have just a globally initialized g plugin info variable, which we just return its reference, its address, and we can initialize it here. So hash this one, and hash define plugin name demo plugin, which we can then use as a second variable, and then all the memory needed will be statically resident inside our DLL. So it will be loaded when the image is loaded into memory. It does not even need more complex initialization, and this already allows us to validate if everything is fine. So first we check if we get if we even find this function, then if we get something that looks remotely reasonable. We could just for demo purposes add this mechanism with this magic number, and since we are here on a 64-bit system, when we look here, we see it shows us the info that this whole object is already 16 bytes long. even though we only use 12 of them. Basically, this is a pointer which is 8 byte long, and it is aligned to a 8 byte boundary. So after our version, there is a dummy unused space which we could use for a magic number. And then we should of course define it, and then always check whether it is. So plugin magic, and let's call it data panel plugin information. Yeah. That we know what the shorthand refers to. So we'll add this here at the right place. And as you have seen, if we don't get the types right, it will complain. Of course, if we would change the order here, we would then need to adapt this as well. So we have this. Then of course set up project dependencies so that once we build data panel, it auto builds our plugin for us. And now we can go to our plugin manager and start loading those plugins. So we already had a list, a mechanism somewhere which enumerated all these plugins here. So basically when it was instantiated, it added those plugin factories, but for now we will just comment this out. We'll add a new function, protected function ideally, void. Because also, yeah, it doesn't matter. And the idea is that the function will load all the plugins it can find from the local working directory or from the application directory. We can choose this right now, and I think we should go with the application installation directory. We could also go with a subdirectory, but then of course we would need to change where the plugins are built to. So for now, for our debug build, it is more convenient to just always go with taking the current application directory. We could even use here a if def debug #else and if to select either a plugin subdirectory in a release build or the application directory in a debug build. But I think that is a unnecessary complication. So we want to of course know our application's path. So q string appdir is equals q application. Application dir path should be it. We can put a quick breakpoint here to quickly see if we get the right value. And well, it is of course like SQT likes it. It's all with forward slashes, but it looks like it's the correct location. It's the debug folder, so it's data panel x64 debug. So when here the DLL will be enumerated, it will be loaded. We also see we actually have here already another DLL, which is not a plugin, so we'll be able to test our mechanism to validate whether whatever we try to load is a valid plugin or not. We could of course add additional sanity checks, for example mandate that every plugin DLL needs to contain the word plugin with its name, or it needs to start with it or end with it, etc, etc. But here I think we will go with the most generic approach, where we just check all the DLLs that we found. As we remember here that it doesn't have a backslash at the end, and I think just to have this demo, we can comment it out. We could have this if ndef debug, then let's call this loaddir plus equals slash plugins. And since we don't want this to confuse us in a release build, we just comment it out. But there you already see how one would approach it if one would want to have the plugins confined into a own location as a sub location of the executable. So now we need to enumerate all the files. So qdir has a function for that. Let's call it dir .list entries. We need to tell it where, so we initialize dir with our path. as you see, the constructor likes to take a path, and here we could add different filters. Also filters as a string name. Let's first see what filters we could add, because for example we might not want to see the dot and the double dot which are present in typical DOS directory. So we will for example go with, we want files and no dot and no dot dot, and that would already be probably good enough for our use case here. So qdir no dot dot, and although actually that is kind of in this case redundant, because a dot dot and just a dot are directories and not files. So if we say we only want files, we can skip this already. And what this thing does is it returns us a string list of whatever it has found. So we can either put it into a variable or use a for each directly. Auto name, comma, zack. You can print name. What we got here that we see. So when we run it, we will see all the different files, which is not yet quite what we want. We would like to limit this to DLLs only, so we can go for the other implementation, the one that takes here this name filter. I'm not sure if I correctly recall the syntax, if it just takes things like this or if it wants something special, but we can just actually, I think it wants a string list, and we can make a string list out of this, but I guess this will not quite, let's see. Yeah, that already worked. We get only the DLL, so if we would have more things, we could just, for example, start with a string, something separator something, and then just split by whatever we use as separator, and then we would be able to get a string list from a single string, which is quite a convenient approach here as well. Usually when using Qt, this is my preferred approach to generate string lists. It is a bit more let's say compute intense, because it needs to actually do the split operation. The other alternative, if you have multiple entries, would be to go with string list and use the shift operator. Oops, I went to the brackets. This also works, and then you can just shift in more and more other things. So you know, I find this often when you are using such lists, they will contain things, not just like extensions, but names or strings that needs to be translated, and then it is really convenient to just tr from one longer string with vertical pipe symbols and then just split it into pieces. But here, since we really will always use the DLL, let's go with this approach. And as you have also maybe noticed, we only get the file names. So to actually get the full path, the full DLL, what we need to do is we need to concatenate loaddir plus / plus name. Qt, even when run on Windows, will always use // wherever it wants, basically everywhere. So if you want to interact with some Windows APIs, then it is necessary to think about always converting those / to backslashes. One thing that one also might want to consider is how would you want to keep the path representation inside of your application. So if you want the default to be the Windows notation or the Qt notation, generally it is it might be more error prone if you stick to the Qt notation, because then you need to remember to change this to Windows each time you do something. On the other hand, here you just need to remember at the beginning. So whether it's really much more error prone will more or less depend on your level of discipline. For our use case, since we are on Windows, we will in the end want to have everything switched to Windows notation. So we go / to backslash. And to note here is that Qt will be perfectly happy receiving paths in the Windows notation. It will not bug out or something, so any Qt function can be called like this. So now we are ready to load our DLL, and we could do this either with the Windows function like library W, or we could do it with Qt's own library load mechanism, which is basically just a wrapper for the Windows version. Since we will be keeping the plugins themselves more or less Qt free, just using standard STL, we will go here with for now using the Windows version, so that we can also use what we have learned from this plugin here. But later, if we want, we might switch this to another approach where we just use the Qt version. Where's the other one? Get ports address here. Okay, so we go back to our project. So we will be loading this thingy. Let's paste in the things that we have copied. Har module. Let's go just h plugin load library v. This will be q string or plugin path. And this thingy UTF-16 gives us already the right sort of string, but it's when we see the return value, it's actually well, storage type, which is char16, which is the same thing effectively like vchar, but it's there is a small difference. So let's see what it's still complaining. It doesn't know that, so we need to include, of course, Windows H. Okay, now it knows the thingies, so we have here our H plugin, get ports address. This will be our where did we define this plugin? Get plugin info. Pair underscore get plugin info. We also need to include hash. What was the name? Yeah, interface API interface or helper one that includes the other. Interface nothing. Helper includes interface. So let's go here with helper. Right here. So here we have our get plugin info, and of course first check is did we get it, and of course was this loaded. So if it was loaded, then if we got something, then we can do it. If we don't get it or we fail to load it, then we just free it, and it just means that it was not a plugin from us. Actually, we could go with yeah, for that, let's go like this. So now we want the info. This info sternpair plugin info is equals. Now we call our function. And now the last check is if plugin info magic number is equals interface plugin magic. So if all those conditions are met, it means this is one of our plugins. We can use it, and then we will be just adding it to our factory. And we will of course need to make some wrapper that will work. So with our plugins, with our built-in plugin, so to say, we have here our plugin factory. So we'll make a derived plugin factory from it. So plugin, let's call it loadable plugin factory. It sounds long. DLL plugin factory. Yeah, that sounds like a good name. Okay, then of course we need to change this and that, and we will need to write something here. Actually, we should keep a reference to this thing once we have loaded the library. So before we continue here, let's have too many. We should pin a few things that will make things more easy to find. Let's actually switch to the Qt version, because we will want to keep a reference. And for some reason, as you see here, the commenting out is kind of broken, because it should comment out the whole line. Let's reopen it. Yeah. Visual Studio and its bugs. So we will need to go to our here. Q. I think that's the correct name. Just Q library. Library. Qs. Well, we will want this as a pointer so that we can refer to it. Qs. Was this like this? Plugin. Somewhere is a typo. Yeah. Library pair is equals create. We should see what we could pass as arguments to AQ library. So we can provide here already a file name, so let's do that. Plugin path. And before we do more, let's just check if this worked. Also, if we want to not type so much, we could just type auto. That would also work. Okay, so library is loaded. If so if is loaded, then yeah, let's print okay or something, just to see if the mechanism works as expected. Let's put a breakpoint here and run it. Okay, it didn't load the library. It might not like the DLL at the very end. So just to look here, it says it. Is it loaded or is it not loaded? Since it is supposed to be like a platform independent approach, it might, I'll just quickly test this, want the name without the platform specific suffix. No, this also didn't work. Interesting. We need to explicitly load it. Okay, then that might also have been the problem, that it first wants to allow it to be called on it. Tag. Yeah, so that works. That is return something. It even returns sports. Actually, we can just check. Test it like this. Right. So we have our library. Get resolve symbol name plugin info. So this path stays the same. Okay, almost we forgot. We removed a bit too much. Let's load it again. Okay, so as you see, we get a valid address and we get an object, which probably is fine. So let's continue. Let's maybe move this here. So the idea is that now we can keep this plugin object, and as far as I recall how Qt handles it, if we if we destroy the last instance of this thing, it would automatically then unload the library. So Qt is kind of helpful in this regard. So we copy the type, go back to our plugin H, and to our factory we will add protected mPeribran. The thing we will want to initialize it always with a library. So plugin factory reference const. This is a very minor optimization. But why not? Okay. This is a smart pointer, so it will automatically get destroyed if this happens, if it's the last instance, and then we only need those two things. So we will just add a few variables here. Let's start with string string id or id. That looks nicer. Name and name. And we need to include here our interface. I should include the interface API interface, so that we can refer. Let's pin this as well to the make plugin type. Stack make plugin make plugin. Good. And here this will be a bit more complex. So we get the library. We know that we got the type, so we assume this function will exist. So we'll make plugin is equals library resolve make plugin make plugin. We also need to set the names and the other things. So let's actually we could make this a bit more elegant here. Put all those things in this. So we want make plugin, we want resolve, then once we have the info. Okay, so only once we have passed the info verification to the next step. Let's make this a bit more multi-line to be more readable. Name we said will be equals let's this be the last thing. Name will be just plugin name. Of course, this needs a conversion queue string from char array. ID will be from the file name we set, so id is equals library punct doesn't that allow us? Yeah, name file name. Is it like the split? That might actually give us the Qt backslash again. Before we do this, let's just go with the whole path, and later we will only get the file name. So here, and then the last thing is to resolve. The last thing that we resolve is make, and we should either add here. No, we can add it here. Add another function is valid. Void is with not void for, which returns if we were able to obtain the needed pointer, which we only even try to obtain. Try that we initialize with ptr. So the idea is this: we go through this function here. We first, for every DLL we find, we see if we find this function. If we find it, then we get the info. If we get the info, we check whether the info is valid, and if it is valid, we do this. And only if we do this, make plugin will become not null. And also, if we even pass all of this, this could still fail if there is another DLL that has this name but not that. So then here we will check if we successfully got something, and it only returns valid if this is not null ptr. So actually, we could even put more functionality into it. We could really just put everything into our plugin and library and replace library with just the file name itself that we would pass here. Const string reference, and now if we know that we've passed the file path always as a DOS formatted path, we can split instantly by \\, and take the last section, which will be basically everything, basically just the file name with the DLL at the end. We could also strip this, but we don't want to do that. Let's just keep only the file name as the ID, and then the valid call here validates whether everything went well. If it's true, then we will continue and add this to the list, and if it's false, then we will just not do that, which will simply result in this thingy. So this will be a to do. This we will still need to do. For now, let's just return an invalid pointer and add a to do. Okay, so we have our plugin path. Then we need our plugin factory, which will be a shared pointer to the plugin factory. We don't have a one defined. Okay, that is fine enough. The plugin factory. We could go with auto like before. Create from path, and if is valid, then we continue by adding it to our list, and else we just continue with the loop. Let's see what it doesn't like. Factories, string, and plugin factory asterisk. Yeah, that should be a smart pointer. Then we need to update this here and there as well. Okay. That might cause, that certainly will cause compiler errors further down the line, but then we will fix those as well. Okay, so let's run it. Let's make it nice. No breakpoints. This is a this is defined in Windows, so let's go with unsigned long. That's the universal version. And as I said, here we will have some bugs that we introduced by changing the type. Actually, this could also be like just auto. And here, okay, so get factory will want to be a pointer, so this will break something here. That will break something there. Okay, so add, and we see it loaded demo plugin correctly. Let's maybe add a space to the demo plugin, to the name of our demo plugin. Yeah, and then we will add a few more. But as you see, it loads it correctly from the DLL. We can also inspect our process with the modules, memory modules, demo plugin DLL. So you see it's loaded, and yeah, so this works as expected. Now, of course, we want the ability to create an instance of it, so this we will also need to add, and then once we did that, we can start calling functions on our loaded plugin. And then we also create some nice wrapper so that we can easily access those things. So go again to plugin, and we will want to create some DLL plugin, let's call it implementation, although since we're actually starting to get more and more stuff here, let's be nice about it and move a few things into the CPP file. Oops, zack, zack. And maybe some separation in name that we know where what starts. In principle, one could also go with creating individual files for every thingy, but here, since those this base functionality is so little, I think we will just go with using the same file. But it would be advisable, of course, to grab those names and use them in the header as well. So we have here plugin without DLL. So the way this is made, we maintain the ability to use also like built-in plugins later. Currently we are not loading them anymore, but we could if we would want to. Here, the plugin factory. Right, so of course our to do here is the next thing that will go into here. Oops, small typo. That's how it should be. So what we do here is we'll be creating a new instance of this thingy. Plugin plugin is equals the plugin pointer from the other plugin. We actually don't yet have defined the other plugin. We just made a copy here, so we should quickly fix this. Okay. And our DL plugin is just derived from plugin, so this also means fixing. Okay, right, so we have our plugin pointer from DLL from a new DL plugin. We can define it such that it will take the pointer returned by our make plugin, so our abstract plugin asterisk will be one of the arguments here. And it will be mandatory, and we should also hold on to it. Plugin name we leave as is. Okay. So we have our plugin instance, then this we will copy. Zack. Then we can copy this. Of course, we then not object, but the actual parent object. So let's see plugin. Zack. And this is like instance. Okay. So here we obviously now need to get this instance. So let's see. Do that. Zack is equals plugin age and make plugin. And in principle, if this is not, then we return a bug, an error, or in this case just an empty pointer. So it could happen that for some reason the function which we call will decide to say, okay, I fail, I cannot do that. For example, if memory allocation would fail or something like that. So this is an important safety check. But if it worked, actually we can just directly return it like this. It doesn't like something. Yeah, it's just complaining that we have not implemented some of those functions here. Let's see what we really need. We actually only need this init function, really. The rest is kind of optional, although we should set a name, I guess. So let's here stay with this approach. Return per we will want to call a set name on it. Set name, and we have already our own name already resolved, so we do that. And then of course we said we need the init function, which yeah, true, so we just say it's fine. Okay, so we have our init function, we have here, it still doesn't like something. We forget to change this. Yeah, we need to change this, of course. And let's add override everywhere where it makes sense. Although actually we don't. Yeah, let's for now let's go with overwriting and with those with more or less not doing anything, because we will want to implement functionality. Since it's a generic wrapper, we will not want to just bug out. We need to extend our interface with all those things. Good, we have the name, we have the instance, we have this, we have that. That should be here already good enough. We have a make to have this thing created. We set the name. That should there is it's complaining somewhere. Let's quickly build it. Does this require an argument? Oh, yeah, apparently made it require an argument. This API thingy, plugin demo, which we have defined here, but we kind of really didn't. Okay. So let's go to our project and add this in the right place. So we said that this would take a malloc and a free. We won't be using this for now, but let's just add it so that we can okay, so that we can use it if we would want to. Okay. So this is it. Let's build the project to see if anything else complains, but it should be fine. Good. So we have loaded the plugin. Now what we are of course missing is the ability to use any of the functions, since we only created it, but everything else is kind of self-contained. So let's quickly see if our demo plugin did something where it just gave us a name and nothing more. And I think the test plugin was similarly without anything. So what we'll want to do now is, for the demo plugin, we'll add the ability to return some data that can then be plotted somewhere. So we want well, start stop we might not care for now. Let's maybe move this up. Since we are here inside the C++, but we can change things easily for now. Let's implement those 5 functions. Plugin cpp, plugin here we have our init, zack. This will of course require the extension of our default interface, but since, as I mentioned last time, we have not made any official public release, we can change the first implementation as much as we want. We don't need to already now start versioning anything. Yeah, zack. So we have those functions. Let's see how we can introduce them into our interface. So the interface abstract plugin. The abstract plugin is quite simple. Okay, this label thingies, we will not use those. And here let's comment this also out. Actually, we can just comment out the whole v2 for now. Version we actually also don't need, because version we get from the factory type. We also don't get the name. We also don't need, because this, as we said here, the name will be just cached on the object when it's instantiated from our, so the name we cache when we instantiate it from here, so this also does not need to be there. And we should also avoid to kind of make redundant information available in multiple places, because then if we want to change that, we wouldn't need to change that in multiple places. So it's more elegant to have like something that just gets the infos from the DLL itself, and then it works and it does what we want. And as we have seen in our demo here, we also created a wrapper object, which we have been using even with the smart pointer thingy. So there we would just cache such things like name and stuff on it. There is no need for the plugin to have this functionality, and it saves on work if we then start making more and more plugins to keep the plugin interface as simple as possible, because this means then that we can we don't need to copy so much code around all the time. Okay, so basically here, actually let's maybe go with all the functions which we have defined. Let's add this start stop as well. So plugin, so we'll add all those functions. Alright, and an init function we could add as well. That might be useful, although we could always use the constructor as init. Oh, and I just noticed we also forgot to call init. Actually, did we ever call init on anything? Or did we just define the function and then I think we actually not even used this, and it was capital I. But we will be using init later on. So for now, it is a bit redundant. The init is kind of useful if you don't have a constructor, or if you want to receive an error value, because the constructor doesn't give you error values. If we should keep it, because if we would be opening, for example, a COM port, then we would want to be able to communicate that, for example, a given port is not available or is busy. So it's good if we can bug out without throwing exceptions. So we have here the thing is the name, as we said, goes away. We have also defined error codes, plugin codes. Then we should move this to our plugin interface. Plugin demo, where was this located? Demo panel, plugins, plugin codes. I just copy this into our interface here, and then here I can delete it and add existing item interface plugin codes. Then we will add those to the interface. Hash include plugin codes. Okay, so we have our init function, which let's go to our plugin with our demo plugin. So here, as we might remember, everything needs to be virtual to keep in line with our pattern. Reset. Okay. Then we go to our demo plugin. And you see it already complains about all the things that are marked as override, which, oh, and I see another problem. We also need to change the types, since this will not work. plugin interface. So here for channel name we'll go with MyString, and here for a vector, why is it complaining? Don't we have? We should have MyString defined. Yeah, defined there. yeah, washed. So the thing that we need to keep in mind is how do we want to communicate things like, for example, here this vector arrays. One could in principle go with using STL objects, but that would limit our binary interoperability. So it would require the plugins and the calling process still be built at least with the same compiler with a similar enough version. So generally this also would not be something that is that would be very much recommended. So ideally we would try to keep here only to own interface types. So we either have to implement some own array similar to the string thingy, or we can return things just by reference, which then would of course have the memory management complications like we mentioned already before with strings, that we would need to manage allocation and deallocation. Since we have passed here the interface somewhere for malloc and for free, to make this a more complete demo, let's go here not with an own object but with the more step-by-step approach. So this will be just some int with the status code, whether it was successful or not, and then we'll of course need to get time samples, get data samples. Those would also be good if those would be kind of synchronized to each other. So let's go with just get samples, and we'll provide both here. So double asterisk, so it's a pointer on a pointer. Data samples and time samples, and int asterisk sample count. Okay, so this will be our definition of our interface. Yeah, and it's not really complaining. So sometimes it gets stuck in some previous error state and shows you complaints which are no longer valid. I don't think there is any problem here. So let's quickly replicate this to our demo plugin. This will of course be an override as well. And here we said we use myString for this one. Oops. Oh, we forgot something. They need to take a channel ID so that we know what data we are requesting. And of course here we add override instead of this 0. For now, let's make this just return in. Was it plugin okay? Yeah. Plugin okay. This let's return true. Actually, we could change this to also return error codes. That would be nicer. Interface int. And what would be even nicer is if we go here and we define as a type hash define plugin status int. Then we can make it like this, and then we can tell this from normal integers apart. This is quite nice. Right here we will also need to it doesn't matter. Those we can kind of retrieve from a cache. Not quite ideal because then always one and then the other. So the problem is here that if we call the other function, we would want like to get both data sets and set them somewhere, cache them, and here just return copies. But then they will be out of sync, so we'll be changing this interface here also to return both at once, just in a different way. Right here, so we have this, so we only need to implement get channel count, get channel name, reset. Do we want that? Yeah, why not? So let's go with those three. demo plugin. Demo plugin. So here it complains because a few things got ratioed away. Zack, zack, zack. Oh, this one is wrong. It should not be virtual and override. It should just be override. Zack, zack, zack. Okay, label we also don't need. Okay, so we have our demo plugin. We said initialization is just always fine. We have here our few. Here we forgot to add the status definition. Let's just copy it again before we waste time fixing the lines here. Zack, 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 zack. Okay, we can quickly take a look how this was implemented in our here with the string returning something. Data panel. Right, so channel count. Oh, that was a bit too enthusiastic of a adaptation because channel count is actually an actual integer. So just an int. This will need to be updated. Plugin status is here, init as well. This will be changed. This is an integer. Okay, plugin here, so init. That will also need to do something. Start. Okay. Right, so here all the types need to be changed. It is not complaining because it's also an int, so it just looks wrong, but it would work just fine. So we have this, we have this. Channel count should be an int, as we said. That should return 1. And here, if index is not 1, let's do it differently. You can also use a switch index. Case 1 default pattern null ptr, so there is nothing. And here set value. What does it take? String or a pointer? So let's call it a demo channel with a space and an L because it's a white character thingy. And that would complain, so it needs to be in brackets. Yeah, good. So we have this. That's a typo. Reset won't do anything. Return just okay. Login okay. To be exact. So here we have API. We don't do anything with API. We should save this. And we should save this ideally on the plugin itself. API. The constructor can get it. API. API is equals PAPI. Okay, so we have now our API to be used. This thing will be using it. We could of course make it even more nice and have here a define like 1 and hash define channel 1 name oops, that's quite not the right thing to do. Yeah, channel 1. The channel count goes incremented, that will be fine enough. Right, yo, so this is so far. Let's go back to plugin. So here we create the instance of the plugin somewhere here. This is again complaining because we changed something about the class definition. So here let's go with this has changed. Yeah, this has changed. Now it's already fixed. Yeah, I didn't just need to think about it. No, it's no longer complaining. And we said we want to change this somehow. We could also just add a function which will just update those data in the cache. That's maybe the simplest solution for us. Plugin status. How did we call it in the interface here? Get samples. Let's call it update samples. Right, and this thing should return an error if it's not implemented. Error not implemented, but we want to implement it. And then here we will create a cache for those things. Samples and data, and this will just always return them. Time samples, data samples, plugin set. That needs to be defined, of course, here, but it is that needs to be virtual. Okay, and now it's just complaining that it's missing this thingy. Zack. Right. So this thing goes away. This will do the update. Okay, so let's see. We have here this instance, which is just a abstract plugin. We could make this nicer by taking our helper, myptr. We had here that already is quite nice to use, so we could use this thingy. It does the release. It was Teref does the release. Yeah, that should do all that we want it to. It only holds the one pointer. Yeah, perfect. Plugin H. So here instead of instance we'll have didn't we include that? Okay, so we have two problems. First of all, there should be helper, and then plugin code is already included, and then this should be also fine. Okay, so instance gets initialized here with the instance, which it doesn't like. Because we said this needs to be called explicitly, so let's do it. And then on instance we can call, for example, here return init. Actually, we could keep this in the header, since these are mostly one-line functions. They look nicer in the header. Oops, get count. Okay, this one is not a one-liner because this will be the get name from index. Let's quickly review how we are supposed to use our string. It's nice. Like this. Oops. So plugin demo. This is then p channel name and if dot maybe that we have a ball operator, that's good enough. So if this is something, then return q string from virtual array, get data, get length, and else we just return an empty string indicating that something failed. Then we have our update samples. So here we go to get samples. Okay, so let's just copy things from here. And channel, we should not forget to set the channel. That's a small oversight. Well, get samples, we don't have channel names here. That is not great. We need to add index to everything, otherwise this will be a problem which complicates things. But of course we want to be able to get data from multiple channels. That's why we added these channels, right? So we cannot just go with not having those. So this will be a q map of int of vector. And data samples will just give us point value on from index. Also, it's kind of not great that we call it index in one place and channel in the other, so let's just be consistent and call it channel everywhere. Okay, so we have this, that looks correct. Int channel. Here we said we change index to channel. This thing needs some name update as well. Index. Here we are really inconsistent. Channel. Okay, that as deep as that goes. That should have all. So we have data samples. This is now a simple pointer. Sample count is not a pointer. This should be p data, p timestamps. It's a null pointer at the beginning. Sample count is null. This thing will return us a status code. It should be a plugin status. Status is equals. Okay, so that was a reference on data sample. A reference on this. Oops. On this, and we want the address of that. So if we define, I think, a checker for that is success. Although I think the name is success might actually be used by something in some other API, so we might want to make this more is plugin success or something like that. Then return this as well. So if this was success, then we can we have forgot channel here. Then we can do something with that. This is doubled. That should not be doubled. Okay. Right here. So our definition of the functions contract will be that if it returns an error, so something that's not success, then it should also not return any memory. Other ways how this could be defined is such that it might actually return some memory and then still bug out. So in which case it would be up to us to clean up. But let's let's make it more strict and say that if it bugs out, it should be cleaned up by the function itself. So we have now here our pointers. So we will overwrite the data in our cache, time samples, and data samples. So this of channel is equals instead. What was it? No, it was a q variant. Q variant double. No, q vector. This thing takes a lot of different thingies, but one should be a list of values. Doesn't it take it? Size and iterators, string. First of all, why is this still complaining? There should be a vector double, yeah, vector of doubles. Then it should let's review the header, because it would be of course convenient if we could just pass the list where it takes a list. This is also there's no constructor somewhere, so there is a constructor. It takes an iterator and different constructors for the list defined. Okay, this is in this. It can size and point at them, but this only initializes one element, all elements, but with one value. This would be the right thingy. Copy, append. This would add multiple elements. Let's see if we can use this nomenclature. So this thing would want date samples. Oops. Date samples, comma date samples plus sample count. And this will initialize the thingy with all the elements. Of course, sample count should be greater 0, but if it would be 0, then it would not do anything, so this is fine. We got those data cached. Then we need to get rid of the memory here, so we call our free. Okay, this should be moved somewhere where it's easier to call, or we just add it to the plugin. Somewhere maybe on the very top. Then we can call it from wherever we want. My free. Right, so we are here. We completed that. My free data samples and my free time samples. The other approach would, if you want to always clean up, would be also that we just check if something was there and then always call free. Since we are not maintaining those memory either way. Let's maybe do it this way. So it looks a bit chaotic. Yeah, that looks nice. Okay, so this should be good enough. So we can call it. Now we of course are missing the doing of something. So let's add here our function. So let's say each time we are called, we'll return 100 samples. With random numbers, and the time we just return one sample, but that's not great. Well, for now let's just go with the simplest implementation. We just create 100 of each and that's it, and then just fill them up. So Asterisk data samples ist gleich mapi myalloc sample count times user of double. Then the same thing again, and this of course needs to be cast to double asterisk. Same thing again, and then for f0 is less than. Also sample count we should have defined as size t to be very correct, but it will also work with an integer. We don't expect more than 4 billion samples, although maybe we do. Let's fix that before it's too late. Before it too late would mean before we have too many things that we need to fix. Size t, just need here an asterisk. Then we of course need to change all the get sample definitions to use size t instead here, and here is already fine. Here, yeah, okay. So data samples from I is equals random number, and time we will just increment by 1 I, for example, and of course tone in okay. So this will be the simplest approach, and now we need to first let's check if we have missed some bugs somewhere. There's only a warning, which is fine, but we also have a few bugs. Right, so the init here, we need to change this to plugin status. Also, this we have removed and no longer overwriting. We can just maybe for simplicity just exclude the thingies from our build for now. So we have our data panel, plugin manager. We had included here the demo plugins. Let's just exclude them. Let's exclude this from build as well. All configurations on Dingstar, exclude from build, yes. This seems excluded. Let's run it again. Already has a body DLL plugin, so we have some small mistake here somewhere. Right. Zack. Okay. And then we have another init plugin, test plugin. Test plugin properties. Exclude from build, yes. We don't want this either, because then we would need to. Okay, and one thingy. We are missing an include somewhere. Output. Helper agent. This is included by plugin CPP. So we need to add this function. I mean, the simplest thing would be to just add Windows H to our plugin definition before we include this thing. This is not great, but it's okay. Makes more things complicated. Okay, but we have better issues. Okay. That is a small mistake with the definitions here. So public, plugin factory plugin, this is public, and that is public. And when we go to abstract plugin, that should be public. That's why we got this error before. apparently we forgot to add a reset. Reset plugin start stop reset. Yeah, we did. Reset. Okay. Good. So now we will need to add code to actually use those functions and plot it to our plot. Are there any questions in the meantime? Okay. So if there are no questions, then let's continue. So we have here our data panel thingy, and I think we really have not yet that much with regard to plotting things. Yeah, we have added the plot, but we have not added functionality to make it actually do something. So let's see what we will need to add. Would go just from the timer and start plotting there. So we go to our timer, plugin data panel, and from the timer get those things, but this is also not ideal. Okay, so I think first things first, we just pin this so that we can easily find it, and now we will add a few objects. We have our plugin manager, which has a list of loaded plugins. Each plugin has a data set, but here what we will want to have is something that will trace the plotting objects. So let's add a helper structure first, stocked as curve that traces one curve. It will has class qwt curve p curve. It will have a copy of the data, so q vector double x data y data x1 data y data. Okay, then we will need to have a map that maps our q map plugins to the data, and here as a key we'll just use the address of the plugin in memory, q64. And each of the plugins can have multiple curves, so we could either just make directly a q vector of curves, or we could make another helper structure stocked as plugin data, which will then hold a q vector of s curves. So if we want to add something else, it's more elegant and less refactoring of code. Channels. One thing we could of course add here directly would be some sort of label, q string name. Right, we have plugin data, channels or mdata plots. How do we want to name this? We could of course just index just the channels directly. That would also be an option. Let's call it plugins. It will contain a list of channels. Yeah, that should be good enough. Okay, so then we need to populate that. Data panel. Where is our load? And remove plugin, add plugin. Okay, so we did this. We have added the plugin. So we have a plugin. Then it's time to update this thingy. So plugins. Add punct data. So we take the address. So the data gives us the raw pointer, which we can cast to QIN64, and here we can, for simplicity, refer this by reference data. So since this is a reference, it's basically like a pointer. When we change something in data, this change is directly reflected inside the map, since the data object here is really just a pointer on, or a reference on the data which are stored inside our map. Right here, so this is channels. So let's first check how many channels we can have. Plugin get channel count. That should also be a size t. Doesn't matter. Channel count, so channels resize to the channel count. Let's see if we actually need to initialize something. This needs to be initialized with null ptr. This is self-initialized. That's fine. We could set the names though. So for int e equals 0 is less than channels e plus plus. Well, it depends on our approach. If we now create the curve directly, then we don't even need the name, because then the name information will be already stored inside the curve. So let's maybe remove that to not have too many redundant information. Do we want to make this differently? We should move this into a helper function. Let's call it update channels or update plugins. And let's call this plugin channels to be more explicit what it is doing. Right here, so we will here just call update channels, and here will be our update channels function, which will be slightly different. So we will here recreate everything from scratch when we add the plugin. So this will clear. This will be cleared. Could also add a helper function, reset channels. That would be reasonable. So let's add first a reset channels, which will clear everything. So the thing is, we have the pointer up there here, and we want to always call the destructor on this, so we cannot just clear the thing just as is without first calling the destructors by hand. Auto plugin, comma, that was called plugin channels. Plugin channels. Oops. Auto von plugin punkt channels, and here channel curve, delete curve. Okay, and when we do this, let's make it look like that, and then we can clear. So we cleared, and we have to go again through all the plugins which actually load that. So we should have had somewhere functionality already here, for example. Zack. So ID is here. Right here, channel. Well, we would want to set it some unique color, and maybe, yeah, color is enough. Let's add a counter. So we have resized channels to the right count. Then data should be consistent in our naming. Let's call this here then data as well. So data channels at E. This thing is from type scurf, so scurf reference is this, so we have curve punct p curve is equals new qwt plot curve %1 point %2 okay, comma plugin get name e +1, or let's give them letters q char a plus e. It will break if we use more than 27 channels, but that should be enough for one plugin. So this is the name, then set pen, q pen, q brush, from color, which we need to define, comma 1, comma, and from style, which we also need to define, and let's see, q color. I'll just rotate through the same colors all the time. Q10 global color qt red plus counter modulo 6. We said we called it count. Let's call it counter. So we will have red, green, blue, magenta, cyan, 1, 2, 3, 4, 5, 6 until here. And those colors we will not use. And then for style, let's just go with one style, qt, solid line. Might be missing something. Yeah. Okay, and then of course curve attach. Curve. Oops. Attach to our plot. Suck. Channels is already inserted. Okay, that looks good. So let's add a plugin, but it's not updating anything, so we will need to add something that stop start will will make it do something. For example, inside of the timer, calling the get function periodically and then updating the data. So let's add a flag. First, let's see whether we have start stop. We have start stop, so let's also have like a global flag whether it started or not. Actually, we don't need it. We did we do the buttons? Do we have normal buttons? Yeah, we have start and stop, so we need a flag. If we would have like a button that logs in, that is checkable, then we could just use its value started. Then we could have used its value. Okay, so here started and like true, stop like false. We have start, we have stop. Then on our timer, so here we refresh the plugins to be reset them up to date, and if this thing is started, then we want to go for all the plugins as well. So maybe let's do it like this. So if it's not started, then return. And if it is started, then plugin update samples. We need a second loop for if e equals 0, e is less than plugin here data channels size e plus plus update samples of I, and then plugin we can get date samples of I that will be set to channel channels at I comma x data. No, that's y data. Y data and x data is time. X data is get time samples. Okay, then what do we need to do then? Let's recall quickly. So we had here our replot, set raw samples, that's what's missing. And of course we'll do a replot, but only once at the very end of our loop here. Data channel, data curve, data channels. From E. Curve. Set raw samples from data channel x data, y data. This needs a dot. X data, y data, y data size. Right here, and plot replot. Only once. Okay. So let's add the plugin, and it's not doing anything. Why? Let's see. So timer runs. This should be set to started. Start didn't start. Then we forgot to connect start. That could be. On stop, on start. Press start. Now we do start. Okay. And if we have not started, here the problem. So we used this trick already before, and now so here, so that we don't run into the same error next time, let's just go with this approach. It's not as pretty, but it's more foolproof. So let's run. Add plugin, start. Well, it's it looks like X and Y would be interchange. That's X data, that's Y data. X data should be time samples, Y data should be data samples. Data samples go from data, time goes from time. That looks correct so far. Here time. Yeah. We flipped it. Add plugin start. Well, it's boring, but it does something. You can add the same thing again. That should not be red. There's a bug in the color picking mechanism. Color. Sure. Counter needs to be incremented. Otherwise, we'll always stick to red. So let's add free plugins, plugin demo 2. This also missing, plugin demo 3, and start. We are still missing the colors here. I looked into it and it really seems that the latest version of QWT is not quite compatible with the newest version of Qt. This is a bug and it's not yet fixed. I don't think it would be a good use of our time if we would try to fix it ourselves. I would just recommend just use the older version of Qt if you want to use QWT. The things that they are improving or fixing there rarely are like real security issues. It's more like edge cases where things can crash or something like that, and the whole thing is reasonably stable. Okay, so we have 15 more minutes. So first question, are there any questions so far? Okay, if there are still no questions, then let's maybe first write a small to do what we would want. So one add parameters to add plugin window. Then we want save / restore plugins on start / close on application start close. Then we want 3 more plugins. And what we would also want is maybe to make the whole display like incremental. Currently it is a bit inefficient because we are always copying everything from the plugin, the whole data blob, and then plotting it instead of like incrementally just retrieving new data in smaller steps. It's not super inefficient because memcopy is quite fast, and even if the plugin would store a very large block, that would then still be reasonably efficient. But if we know that the plugin doesn't need to know the older version values, we could extend the interface such that it would tell us whether what it returned is like the full data blob, or if it is just like an incremental, meaning it is supposed to be appended to the things that have been previously requested. So I think this is let's only have a few minutes time, so I think this is a good extension, the functionality of our interface. So we have here this channel, data, things and things. We just add another parameter which will allow us to do such incremental updates. So ball is incremental, and the idea is that this parameter it can be null, in which case means that the caller doesn't want incremental data. The caller wants a full data blob, and if this is a pointer to a boolean, then it means we can return incremental data if we support that, and then we will set the value to true or false depending on what we are returning. So let's go for our sample. So it's defined here, and we use it there, and it's defined here as well. So let's add it. So for now, to be consistent with our current approach, if this, then asterisk this is like well, actually it's true because we only can do incremental. But we would want this to be, of course, then extended. So we go to our user here. Let's just go with this full incremental false. Give it some initial value, comma reference, and if this is incremental, then we know that this should be append. Should always append instead of just overwriting, but of course this is a small mistake because we need to of course check. So if this is incremental, then we do this, and if it's not, then we should have just kept the code as it was. So let's copy it as suck. Right, so if it is increment, then we append. If it's not incremental, then we just overwrite. And then we always get rid of whatever samples we've got. So now when we run it, it will already be nicer in as far as that it will add... that will keep we always start at the same time, which is kind of not correct. We need to make the data more realistic. Okay, since our plugin is where is our plugin? Demo plugin. Since our plugin has an internal state, let's just keep it. Sample count 0. Okay, but this now means we need to make it something. So reset will reset this to 0, and this will be just sample count plus yo. We have defined get samples as const. That is of course not ideal. Let's just define it not as const. We could alternatively, of course, we define that variable as mutable, but since in normal operation we expect this get sample to potentially change the state, then we will not want it to be a const. Also, we got a warning, but it doesn't matter. Okay, I'll add, and now it works. Although it's kind of not quite right, since was supposed to be a date and not just a counter. So we could go with the date. Let's quickly check here. I think what we had here as the date was in microseconds. Was this msec? Yeah, it's in milliseconds. Then how do we fix that? So the problem that we will be running into is that I think on Windows the normal time function just gives you the thing in seconds. Plugin. Let's include hash. I think we already included Windows H. Did we? Not here. Here. Not here. Okay, then we need to include it. Hash include Windows H. And the normal time function was it get time? I think it was just called time. Maybe it was defined in a different header. The thing is, it returns in just in seconds, and if we want to get in milliseconds, we need some special Windows function, which I don't recall its name right now. So for now, we can just leave it like this. Just let's add a to do get the real time, or actually, we could try to just but why is this not included? That should be... Okay, we need to include time H in this case, then not Windows H. Time H. I mean, if we say that we only call this once per second, then we could just then start incrementing it. It would be a bit of a dirty hack, but it would work. We'll also see if there is some here, something. No. Something that suggests that we could get time spec 42. I'm pretty sure one of those functions will do what we want it to do. but I'll look it up for later. For now, we'll just go with a very hacky hack. We just get time now, and this has a 1 second resolution, and then we'll just go with this plus I. So this times 1000 plus I. And since we have only 100 samples, we can go with I times 10. This will give us somewhat fake milliseconds. We just need to ensure that in our data panel we set the timer to run only once per second. Where is it here? Timer, yeah, here not 100 times per second. Yeah, just once every second. This might of course still have like different UTC offset or something like that, but should at least give us a date close to plausible. Well, 1707. That looked actually like the right time. Yeah. So as you see, it's kind of working. It's not ideal, but well, it's a quick hack. Another thing, of course, what we could do is we could add an on thread that would be running in the plugin and generating those data in somewhat more of a reliable manner, and then would just return those data or a copy of those data depending on what we want. But as you see, we already have something that behaves somewhat nicely. So now what we need to think if there is anything easy enough as a homework, and I think there is. So 13th 11th 2025, implement a WaveGen plugin which has the following channels: A sine wave, B square wave, C sawtooth wave. Yeah, that's enough. A fourth one would be nice. So let's say we want a sinus, we want a square wave, we want a sawtooth wave. We could well, a sawtooth is like like this, and a wait, this. So I think you get the point. So the sawtooth, it rises and then falls to 0, and then rises again and falls to 0, while a triangle rises to full, goes down to minus, goes down to plus, goes down to minus, or goes down to 0. The offset is not really relevant. Square wave is yeah, let's I would need like a upper dash line, which I don't have on my keyboard. Yeah, but I guess people know what a square wave is, so this should be good enough. So basically, we are creating an own DLL based on how we did the demo plugin here, and then you just this is fine. Switch channel. Actually, time can also be outside. Case 1. And then you just modify the function which generates this, and of course wanted to one is right, yeah. It's really annoying that the default indentation for this thingy is like this. This is really confusing. Default, and default will of course give an error. Return plugin. I don't know. What do we have to not implement it? Let's make a new one. For error invalid index. Invalid channel ID. Let's be more explicit about what's wrong. Right, so that is semi-good because then we have allocated memory and we did not clean that up. But we said we are responsible for cleaning up, so... but we implemented it such that it doesn't matter. Because on plugin here we always clean up. So let's just keep it as is. And that's it. And samples. Yeah, and this will always be incremental, or you could change that if you want. Basically, it's as I said, it's quite simple. You just duplicate the plugin, give it a known name, and here add more channels and change this to 4 and stuff like that. Maybe give nicer names to the channels. We already have here our default, which returns the channel names as you would like them. So I think this is a reasonably easy homework, and you can also then test it just by checking if it looks nicely when it runs, that it provides the 3 different waveforms, 4 different waveforms that are requested. Just add it once. Which brings me to a to-do for later for the next lecture. For adding all channels in the plugin tree. So we want to see every channel in the plugin tree, and then we could even add the functionality to, for example, change the plugin channel color, name, style, etc. So then we could set the color from a whole color palette. There is a color picker object in Windows, and Qt implements it also for any other platform. So you can then easily select the color from the full range that the hardware supports. And we will of course think of more to-dos for later. But I think these should be good enough. Since we were a bit over time in the exercise in the morning, then today let's be a bit under time. If you have any questions, you can still ask them. If not, I'll just stop the recording and the screen sharing.